Hi everyone, this is Dr. J. Ravindranath Reddy working as Assistant Professor of Mathematics in MLR Institute of Technology, Hyderabad. So we are in the course of numerical methods and integral transforms. In that course, we are discussing the concept of numerical solution of ordinary differential equations. So to find out the numerical solution of ordinary differential equations, we are having many number of methods, but we are discussing how to find out the numerical solution of this ordinary differential equation by using a Runge-Kutta method. So in this video, we are going to discuss the Runge-Kutta method to find out the numerical solution of ordinary differential equations with an example. So when we take this Runge-Kutta method, we are having different orders. So but we will concentrate only on the fourth order RK method, because the third order, second order and first order, this comes under modified Euler's and similar to the modified Euler's method and so on. So we will concentrate how to apply this fourth order Runge-Kutta method. So this Runge-Kutta method is a very powerful method. So whatever the numerical solution you will get by using this Runge-Kutta method, this is more accurate than compared to its previous methods. So as usual, as we discussed earlier, if you want to apply this Runge-Kutta method, we want the different, this is possible only for the initial value problems of the differential equations. That is, we want differential equation along with the initial condition. So Runge-Kutta method, so already we said that this is high accurate numerical method when we compare its previous methods. Because why it is very accurate here? Because here no need to find out the higher order derivatives of the given function. So in the Taylor series, we have to find out the higher order derivatives. That is the main demerit of the Taylor series. But in this Runge-Kutta method, no need to find out any higher order derivatives for the given function. So we can use that function directly. We can find out the solution using this Runge-Kutta method. And whatever the solution we get by using this Runge-Kutta, that is more accurate than compared to the previous methods what we have discussed. So here, so this fourth order Runge-Kutta method often used Runge-Kutta techniques. So here we are having different methods here, different slopes, but we are using Runge-Kutta method to solve the differential equations here. So this is used to find out the approximate value of a given point x by using this Runge-Kutta method. So this is applicable to find out the solution for these first order differential equations. Now we will go for the fourth order RK method formula. So this is our standard formula we will use to find out y1, y2, y3, y4 and so on. So by substituting I is equal to 0 here, you will get y1 value, and if you take y is equal to 2, we will get y2 value, and so on. By substituting different values of y, you will get different values for y, we will get different values of y, like y1, y2, y3, y4, y5 and y6 and so on. So here this Runge-Kutta method includes k1, k2, k3, k4. So first we have to find out these values. K1 is equal to, he has given k1 is equal to h into, so f of x1, xi comma yi, and f of this, f of x suffix I plus h by 2 comma y suffix I plus k2 by 2. This is the formula we will use to find out k3. And similarly, if you want to find out this k4 value, h into f of x suffix I plus h comma y suffix I plus k3, its previous values. So these are the standard formulas we will use to find out k1, k2, k3, k4. And after finding this k1, k2, k3, k4, if you substitute these values in the standard formula, then we can get our required y values here at a particular value of x. Now let us take the example here. So apply fourth order RK method to find an approximate value of y when x is equal to 1.2. in steps of 0.1. In steps of 0.1 is nothing but the step length, which is represented with h value. So here he has given h is equal to 0.1 and he taken a x is equal to 1.2. So here this is the differential equation. This is the initial condition. So from the initial condition you will get x naught is equal to 1. Now if you take the difference between this x and x naught, you will get the difference as 0.2. But in our problem he has given that difference is equal to 0.1. So what we have to do? We have to divide this interval 1 comma 1.2 into subintervals. The length of this subinterval must be equal to 0.1. That is 1 comma 1.1, that is one is subinterval, 1.1 comma 1.2, that is another subinterval. So these are the values of x we have to consider here. So now let us start how we can apply this fourth order RK method to find out the solution at the values of x given. So as usual, take the differential equation y dash is equal to x square plus y square, and the initial condition y of 1 is equal to 1.5. So this x square plus y square we can consider as f of x comma y, and this one we can consider as x naught, and this 1.5 we can consider as y naught. And the step in steps of this 0.1. So in the steps of means the step length, that is represented with h. h is equal to 0.1. This is the data given in the problem. Now by using this data, we have to find out the values of x1, values of y1, y2 at x1, x2 values here. So now, so that x1 is equal to 1.1 and x2 is equal to 1.2. So as we discussed earlier, if we construct the table here, so x values, y values. So first x value is x naught. He has given that value is equal to 1, and y naught value he has given as 1.5. And now what we have to do is we have to get the x1 value here. So we know how to get this x1 value, that is x naught plus h. X naught is equal to 1, h value is 0.1, so you will get 1.1. At 1.1 we have to find out y1 value, and next we have to follow the same procedure until we get 1.2 here. So x2 is equal to x1 plus h. x1 is equal to 1.1 and add 0.1, you will get 1.2. So at this x value we have to find out that y value. That y value is represented as y2. So our task is finding y1 value and finding y2 value here. So from this we can take x1 is equal to 1.1 and x2 we got that x2 is equal to 1.2. At these two x values we have to get the solution for the given differential equation by using RK method. So now step 1. Step 1 is I'm interested to find out this y1 first. So y1. So after finding this y1 only it is possible to get this y2 value here. So now we'll see how to get this y1 value. So to find y1, that is y of x1. So by using RK method, take the formulas. So y1 is equal to y0 plus 1 by 6 into k1 plus 2k2 plus 2k3 plus k4. So this is the formula we have to find out our y1 value. So first one by one find out that k1 value, then find out k2, k3 and k4. So after finding k1, k2, k3, k4, you substitute these values in this formula, then we can get our required y1 value here. So no need to go for any approximations here. So directly we will get our required y1 value by substituting k1, k2, k3, k4. Now we will see how to find out that k1 value here. So k1 is equal to, we have the formula, k1 is equal to h into f of x0 comma y0. So since you are finding the value of y1, so we have to consider x0 and y0 as the initial approximations, sorry, initial values here. So here in the function, in place of x we have replaced with x0, and in place of y we have taken y as y0, because x0 and y0, we have to consider initial values for y1. So now h as usual 0.1 and f of x0, we got that x0 is equal to 1 and y0 is equal to 1. So now substitute this f of x0 comma y0. So this is our x0, this is our f of x comma y. Replace x with x0, so you will get x0 square, and replace y with y0, you will get y0 square. So x0, already we got that value 1 square plus y0 1.5 whole square. Now simplify this, you will get our 0.325. That is our required k1 value to find out y1. And similarly follow the same procedure here and get k2, k3, k4. So now this is our k2 formula. k2 is given as h into f of x0 plus h by 2 comma y0 plus k1 by 2. So h is 0.1. Simplify this, so you will get this value and substitute this. This you consider this as x value and this as y value. So replace f of x comma y. This is our standard function throughout the problem, x square plus y square. So replace, in place of x replace with this value, and in place of y replace with this value. Then simplify, you will get our k2 value, that is 0.3866 here. And follow the same to find out our k3 here. So this is a formula to find out k3 here. So k3 is equal to, this is the formula. Follow the same procedure of k2 and get the value of k3. So this is our k3 here, 0.39698. Now finally go for k4. So find out this. This is the formula to, you have to remember these formulas. So h, substitute h value as 0.1 and the function x0, that is 1 plus h 0.1, you will get this value 1.01, and y0 plus k3, y0 we got that 1.3 plus 0.3968. You add this, you will get this value 1.89698. So now replace the function f of x comma y is equal to x square plus y square. So in place of x replace with this value, in place of y replace with this value and simplify, and then you multiply with 0.1, you will get our k4 value. So this is our k4. Now in our hand we are having k1, k2, k3, k4. Now you substitute these 4 values in the standard formula to find out y1. So y1 is equal to, so y0, that is, so this is our formula, y1 is equal to y0 plus 1 by 6 into k1 plus 2k2 plus 2k3 plus k4. This is the formula. So in place this, substitute all these values what we got in place of k1, k2, k3, k4 and simplify. This is our final value. Here we will get y1 is equal to 1.8955. This is our final value of y1. Follow the same procedure to find out y2 using this RK method here. So step 2, we are going to find out y2 value here. So this is the formula. Since if you want to find out this y2, we have to consider y1 and x1 as the initial values. So in place of this y0, we are replaced with y1 and keep this k1, k2, k3, k4 as it is here. So while you are finding this k1, so we have to replace x0 with x1 and y0 with y1, because we are taking x0 and y0 as the initial values to find out y2 in the previous step. So substitute, similarly follow the same procedure. Our x1 is 0.1 and y1, whatever the value we got in the previous slide for y1, we have to consider this value here. So simplify this, so you will get k1 is equal to 0.48029, and then go for k2. Use the same formulas to find out the K2 values, but replace x0 with x1 and y0 with y1. So simplify this, you will get our K2 value here. K2 is equal to this. And similarly K3. So simplify this, we use this formula and substitute the values which we got. X1 for x1 and K1, K2, K3H, all these substitute here. You will get our required K3 value here. And then finally go for K4. Take the formula and substitute the values. You will get our K4 is equal to 0.77261. So now, in order to find out Y2, we want K1, K2, K3, K4. Now all these values we got. And now our final step is substitute this K1, K2, K3, K4 in the standard formula. In this formula, we can get our required Y2 here. So after substituting all this in the standard formula, we got Y2 is equal to 2.5043 at x is equal to 1.2. That is our required Y2 value here. So these values of Y which we got by using this RK method or Runge-Kutta method, these values are more accurate than the previous methods here. So this is the way how we can apply this RK method to find out numerical solution for the given differential equation at the particular values of x. So in this session, we have discussed how we can apply this RK method to find out the numerical solution for the ordinary differential equation. So with this concept, we can complete the numerical solution of ordinary differential equation. Then in the next video, we will go for the Laplace transforms. Thank you.